Hey you guys, it's Miss All Day again. Welcome back. Algebra 2, General, Child's High School, Remote Online Learning, Day 8. So let's go ahead and put today's date up here. It's April the 8th of 20. And this is going to be part 1. We're going to take 7-2 and we're going to break it up into 2 sections or 2 days. So part 1 will have 2 pages worth. And then I don't remember for part 2 how many pages there are, but we'll figure that out tomorrow. All right, let's start with what does the parent graph look like for an exponential function? So the parent graph is going to look like what we've been working on. Y equals b to the x. Remember, b was the base and x was the exponent. All right, let's go over the exponential function's general form. It looks pretty familiar, not similar, sorry. Okay, so let's look at a first. A, when we were talking about it yesterday, was the y-intercept, right? So let's look at it. If A is negative, then the graph is going to be reflected over the x-axis. So let's write that. If A is negative, it's reflected. All right, let's move on. If the absolute value of A is greater than 1, then that means it's going to be a stretch. So like if A is 2 or if A is negative 2, it's going to be a stretch. And it's going to be a vertical stretch. All right, if the absolute value of A is less than 1, for instance, if A is 1/2 or if A is negative 1/2, that's going to be a vertical compression. So we've really already talked about that. All right, I want you to look at the x minus h. I don't like the way that's worded, so we're not going to look at that. Look at the x minus h. Remember, that's the part where we used to say, okay, that's a liar, because you look at it and it's not what you think. Okay, so this is going to tell you whether or not you're going to go left or right. So if you look at a problem, and for instance, this one right here, you see the plus 5? That's really a minus 5, because when you put a minus 5 into the general form right here, when you do minus a minus 5, a negative times a negative makes that a positive. So it's the opposite of what you see. All right, so we have x minus h. So now let's look at k. Right here we have k. K is going to tell you whether or not you are going to go up or down. All right, so h, remember, is left or right, and that's going to be a horizontal shift because left and right is horizontal. K is up or down, and that's going to be a vertical shift. Okay, up or down, it's a vertical shift. All right, let's try these out on some of these functions that we have below. These are exponential functions. For each function, identify the transformation from the parent graph. Here's the parent graph. So the first thing I want us to do is let's find the parent graph. Here's b and here's x. It's that easy. Y equals 3 to the x. All right, the next thing I want us to do is let's define all of the numbers. So for instance, 4, what is that? Well, that's A. A is 4. All right, 3, what is that? Well, that's B. We've already used that one, so we're not going to use it again. We don't have an H in here. So if we don't have an H, then H has to be 0. The 2 is our K. The 2 is our K. All right, so now we're going to describe our transformation. So y equals 4 times 3 to the x plus 2 is the parent graph, which is y equals 3 to the x. And let's see what it's doing. Let's start with the 4. That is going to be either a compression or a stretch. Since a is greater than 1, it's going to be a stretch. So we're going to say the parent graph is vertically stretched by a factor of 4. All right, now we don't have to say anything about h because it's 0. So the next thing we're going to do is say something about k. And, all right, k tells me whether or not I'm going to go up or down. Well, going up or down is vertical too. So it's and vertically shifted is the word we want to use there, up 2 units. All right, so that's our first exponential function. Let's look at our second exponential function. We'll use green at this time. All right, the first thing I want us to do is figure out the parent graph. So here's the 1/2, and here's the x. That's the only part you're focused with. Y equals b to the x. So that's 1/2 in parentheses and to the x. All right, the next thing we're going to do is let's define all of our letters. A, B, H, and K. We're going to find those each time. All right, A is really right here. It's a -1. B is 1/2, and we've already used that one, so we're not going to use it again. Now H, remember, that's the liar. It's the opposite of what you see. I see a +5, you see a +5, but we're going to put a -5, okay? So that tells us that we're going to go left 5. All right, so let's describe the transformation. Y equals -1/2 to the x plus 5 is the parent graph, which is y equals 1/2 to the x. And we're going to do shifted. We'll do the shifted part first. Shifted. Now, remember what H tells us. It's a horizontal shift. So shifted horizontally, because that's right and left, right? And since it's a -5, it's horizontally left 5 units. Shifted horizontally left 5 units. You could say that a lot of ways, but that's a fine way to say it. All right, so we've taken care of that. We don't have a K, so we don't do anything with that, but we do have to take care of this -1. Now, whenever you have a 1, you don't worry about whether it's stretched or compressed because it's not. It's not either one. So we just have to do the negative. That negative tells us it's reflected. So, and reflected over the x-axis. All right, problem number 3. I'm going a little bit quicker because this is a little bit longer lesson. All right, here is my parent graph. Y equals 2 to the x. All right, what is my A? It's 2/3. My B is 2. I've already used that one, so I won't use it again. My H, I don't see an H, so it must be 0. So we're not going to really use that one. And then what's my K? -1. So you're going to focus on the 2/3 and the -1. So y equals 2/3 times 2 to the x minus 1 is the parent function, which is y equals 2 to the x. And let's go ahead and do the 2/3. That's going to be either a stretch or a compression. Since it's a fraction, it's less than 1, it's going to be a compression. So vertically compressed by a factor of 2/3. And the K tells us whether we're going up or down, so that's vertical too. And vertically shifted, since it's a -1, we're going to go down 1 unit. All right, let's look at our next one. Let's look at our B and our X to get our parent graph. So y equals 2/3 to the X. All right, let's see what our variables are. A is -3/2. B is 2/3. We've already done that one. We don't need it again. H is the opposite of what you see, so it's 6. And K is 4. Now, if you need to put a plus in front of those to help you remember, that's fine. All right, so y equals -3/2 times 2/3 to the x minus 6 plus 4 is the parent graph, which is y equals 2/3 x. And let's do the negative part first. So reflected over the x-axis, All right, while we're still doing A, we have to talk about 3/2. 3/2 is greater than 1. So we're going to say that it is vertically stretched by a factor of 3/2. Okay, we have an H and a K to do. And shifted. Okay, let's do the H first. That's our left and right. So it's going to be horizontal. So shifted horizontally 6 units. Or I'm going to put, instead of 6 units right, I'm going to say right 6 units. I just like how it sounds better. Right 6 units. And we're going to go up 4 units. And vertically up 4 units. All right, so we looked at 4 different exponential functions and we described them. All right, go to the second page. We're going to make a table of values and we're going to graph each function. All right, the key here, I want you to write this up here. What is H? That's the first thing you need to do. All right, so look at this problem and what is H? Well, I go right here and I don't see H. So H has to be 0. That is your starting point. That's what's going to help you fill in this table. So take that 0 and put it in the middle of the chart like I like to do. I'll try to close it, make it a little bit better. Now, remember, you're going to do 3 numbers to the right and 3 numbers to the left. So it doesn't really matter which order. 3 numbers to the left, -1, -2, -3, 3 numbers to the right. All right, so that helps me choose. Now all I have to do is go plug them in and graph them. All right, so let's start with the -3. I'm going to put a -3 right here. All right, I'm going to do all this in black. So y equals -1/3 to the -3. Now, what I would like to do, because this is the easiest way of doing it, there's 2 ways you can do this, is go ahead and take this and flip it. That way you can get rid of that negative if you flip it. So you have the negative out in front. That's still there. You flip the 3/1 and you turn the -3 exponent into a +3. Okay, so now you have, I'm going to move that H equals 0 out of the way for a minute. Now you have -3 to the 3rd. Well, 3 to the 3rd is 3 times 3 times 3, which is 27. And then you put the negative out in front. So that's -27. All right, let's graph that. Oh, we can't. It'll fall off the graph. All right, let's go to our next one then. Okay, -2. We're going to do the same thing with -2. All right, so we're going to do -2. So I'm going to flip the 1/3. Negative's still on the outside, but I flip the 1/3 and do 3/1. And I change the -2 exponent to a +2. All right, so there's a negative on the outside, and then it's 3 squared. So negative, and then 3 squared is 9. So that's -9. We can graph that one. -2, -9. All right, let's put the -1 in there. All right, so I have a -1. We're going to flip the 3 and the 1. It's going to make it a +1. So that's going to be a negative on the outside. It stays, but the 1 is just a 1. So 3 to the 1 is 3, so -3. All right, let's graph that one. -1, -3. All right, let's put a 0 in there. All right, anything to the 0 is 1, but then you still have to put that negative out in front, so -1. So 0, -1. All right, let's put a 1 in there. There's a negative out in front, and then there's a 1/3 to the 1, which is 1/3, so -1/3. So 1 and then -1/3. All right, let's put a 2 in there. We have a 2. So we have a negative out in front. So 1 squared over 3 squared. So that's negative 1 over 9, negative 1/9. All right, let's graph that one. 2, negative 1/9. All right, let's go put a 3 in the picture. Negative still on the outside. We have 1 cubed over 3 cubed. We have a negative on the outside. 1 cubed is 1, and 3 cubed is 27, so negative 1/27. All right, let's go ahead and draw our exponential function. Refresh your memory on the asymptote from yesterday. Get a different color, and we're going to do the green dashed asymptote. Remember, this is the line that the exponential function gets closer and closer and closer and closer to, but never touches. Now, do you remember what that line was? That is y equals 0. That's what the asymptote is. So if you look below the graph, you'll see where they want to know the asymptote. So that's y equals 0. Now, if you remember from yesterday, the range is going to use that y and 0. You just have to go up to the y, and you have to tell me, are those numbers right there greater than or less than 0? They're all less than 0. So you put less than sign. Now, if you remember from yesterday, the domain of an exponential function is all real numbers. All right, so I want you to look at something. Let's go back to the page before. You don't have to change yours. Just look here for a minute. Sometimes we know what h is, and sometimes we know what k is, and sometimes we know what both of them are. But for this one right here, our h was 0. So what was our k? Our k was also 0. So I just want you to take note of that. Let's write that here. Let's say for this one, our h was 0 and our k was 0. And we're going to see something in a minute that happens with that. All right, what is h? That's the first thing we have to do is decide what h is. All right, right here, the opposite of what you see. H is negative 5. Do you see a k? I don't see a k. So k must be 0. So that negative 5 is what helps us start our chart. So negative 5. We're going to do 3 to the left and 3 to the right. So to the left is negative 6, negative 7, negative 8. To the right is negative 4, negative 3, negative 1. All right, so we're going to plug those in. All right, I'm going to do my work over here to the left. So I'm going to plug in a negative 8. I'm writing in red. Negative 8 plus 5 is negative 3. So if I have 1/2 to the negative 3, I'm going to flip the 1 and the 2, make it 2 over 1, and now that negative 3 just became a positive 3. So 2 cubed. That's 2 times 2 times 2, which is 8. All right, next number, negative 7. Negative 7. Negative 7 plus 5 is negative 2. So I'm going to take the 1/2 to the negative 2. I'm going to flip it and do 2 over 1, and that changes my negative 2 to a positive 2. So that's 2 squared. 2 squared is 4. All right, negative 6. Negative 6 plus 5 is negative 1. So 1/2 to the negative 1. I'm going to flip it, do 2 over 1, and my negative 1 changes to a 1. And so that's just going to be 2. Now let's go ahead and graph those. Negative 8, 8, negative 7, 4, negative 6, 2. All right, we'll finish doing them now. Negative 5 plus 5. I'm going to do these in black. That's going to be 0. So 1/2 to the 0 is 1. All right, we'll graph those in a minute. All right, let's do 1/2 to the negative 4. So negative 4 plus 5 is 1. So that's just going to be 1/2. All right, so we're going to do negative 3. Negative 3 plus 5 is 2. So 1/2 to the 2. You have to do 1 squared and 2 squared. So it's going to be 1/4. All right, our last one for this point, this ordered pair, is -1. So -1 plus 5 is 4. So 1/2 to the 4 is 1 to the 4, which is 1. And 2 to the 4, 2 times 2 times 2 times 2, which is 16. All right, so I see what I did here is I skipped the -2. That's okay to do. I went ahead and did a -1, and I got 1/16. But I'm going to go back and do that -2. So I'm going to erase this -1 here. That's going to be -2 plus 5. I'm right here. So -2 plus 5 is 3. And 1/2 to the third is 1/8. I just did an extra point. All right, let's go plot those points. We're not going to plot that last one, though. It's too hard to plot when it gets so close to that line. All right, so we have -5, 1. We have -4, 1/2. We have -3, 1/4. We have negative, see how hard it is to graph it? All right, so let's go ahead and graph it. It'll come really, really, really close to that line, but it's not supposed to touch it. All right, that's our exponential function. And let's do our asymptote. I'm going to do a dashed line in green. Now it's on the x-axis again, so it's y equals 0. All right, so let's go fill in some information about this graph. The asymptote is y equals 0. We already know the domain is all real numbers. The range is something having to do with a y and a 0. So go look at your y's, and all those numbers are what in relation to 0? Greater than or less than? They're all greater than. All right, I want you to notice something. All right, so what I want you to notice is when k is 0, I'll circle this in pink. When k is 0 and when k is 0, look here, your y is 0 and your y is 0. Your asymptote will be y equals 0. When k equals 0, then y will equal 0. All right, 2 more. Remember, you got to find h first. So what is your h? I don't see one, so my h must be 0. So that's what I start with. All right, and I do 3 to the right, 1, 2, 3, and 3 to the left, -1, -2, -3. Now let's go ahead and figure out what our k is. -1. So remember a while ago when I said k was 0, then y was 0? So look here. If k is -1, I bet you when we get finished that y is going to be equal to -1 because k is equal to -1. But we'll find that out in a minute. All right, let's go ahead and plug in our x's. So I'm going to put a 3 here. Now, remember, you have to do the exponent before you can multiply. This is a common mistake. People multiply the 3 times the 2, and they say 6 to the third, and that's incorrect. Okay? It looks like this. 3 times 2 to the third minus 1. You have to do the 2 to the third once. I mean first, I didn't mean to say once. So 2 to the third is 8. So 3 times 8 minus 1. So that's 24 minus 1. 24 minus 1 is, bang, 23. We can't graph that one, so we're going to move on. All right, the next one we're going to do to the second power. All right, so this is going to be a 2. So 2 to the 2 is 4. So 3 times 4, which is 12. 12 minus 1 is 11. All right, let's do it to the first power. That's just going to make it a 2. So we can just say 2 times 3 is 6, and 6 minus 1 is 5. All right, let's do it to the 0. Anything to the 0 is 1. So 3 times 1 is 3, and 3 minus 1 is 2. All right, let's do this to the -1. This is the tricky part, okay? So watch this. 3 times 2 to the -1. Put this over 1. Take the 2 to the -1. Bring it down. That becomes 2 to the 1. And so the 2 to the negative 1 is no longer in the numerator. So look at that. That's 3/2. That's what that is. 3/2 minus 1. Well, 3/2 is really what? 1.5? So 1.5 minus 1 is going to be a half. All right, let's look at the next one. It's going to be -2. It's going to be very similar to what we just did. 3 times 2 to the -2 minus 1. All right, put this over 1. Take the 2 to the -2, bring it down, and make it 2 to the +2. And then erase this one. It's no longer there anymore. So that's 3/4, right? Because 2 squared is 4. All right, so I'm just going to write that as 3/4. All right, what is 3/4 minus 1? 3/4 minus 1 is going to be -1/4. All right, now let's do -3. All right, this is going to be to the -3. So we know that we're going to end up bringing that down, and it's going to be a +3. So that's 3 over 2 times 2 times 2, which is 8. 3/8 minus 1. All right, the easiest way to do this is take the -1, and you want it to have a denominator of 8. So 1 times 8 is 8, and -1 times 8 is -8. So we're going to change that -1 to -8 eighths. So that'll be easier to do. So that's going to be -5/8. All right, let's go graph those. We can't graph the first one. We're going to graph the second one. 211, it's going to be about right here. 1, 5, 0, 2, -1/2, -2, -1/4. Oh, I went under that line. I hadn't done that yet. -3, 5/8. Okay, we're going to connect our little dots here. Well, that was a little bit different. Look what our asymptote is. It's this line right here. I'm kind of drawing it thick just so you can see it. What is that? Well, that's y equals -1. Well, look down there. What did we say it was going to be? If k equals -1, then our y was going to equal -1. That's a good way to check if we did it right. So y is greater than or less than -1. Go look at your y's. What are they? They're all greater than. They're all greater than -1. And then your domain is going to be all real numbers. All right, last one. Let me erase a little bit so we can not feel like we're all crowded in there. Remember, what's your h? So it looks to me like h is 2 because it's the opposite of what we see, right? And then what's k? K is 4. All right, well, it looks like that we can go do our asymptote. Y is going to equal 4. Let's go ahead and draw it. Let's see what happens if we go ahead and draw it. Go to the y, find your 4, and draw that neon green or whatever color you're doing. That's your asymptote. That is y equals 4. All right, our h is going to help us get started in our table. So our h is 2. So we're going to do 3 to the right. So 3, 4, 5, and 3 to the left. -1, 0, 1. All right, let's go ahead and start with our 5. 5 minus 2 is 1. -2 times 3 to the 1 plus 4. So that's really -2 times 3, which is -6 plus 4, which is -2. All right, let's do a 4. 4 minus 2 is 2. So -2 times 3 to the 2 plus 4. Well, 3 to the 2 is going to be 9. All right. -2 times 9 is -18. Doesn't look like a -18, but it's supposed to be. Add 4 to it, and you get -14. All right, let's plug in the next one, which is 3. 3 minus 2 is 1. So that means this is really negative 2 times 3, because 3 minus 2 is 1. It's negative 6 plus 4. I feel like I did something wrong. Hold on just a second and let me check. I see what I did. I'll show you in just a minute. Let's go ahead and finish this one. Negative 6 plus 4 is negative 2. Okay, we're going to go back to 5 because I messed up there. We learn from our mistakes, right? All right, so 5 minus 2 is 3. Negative 2 times 3 to the 3. I didn't put a 3 there. I put a 2 by accident. Sorry about that. 3 times 3 times 3. 27. So negative 2 times 27 plus 4. All right, so negative 2 times 27 is negative 54. And 54 plus 4 is negative 50. I thought something was looking a little wrong because I knew that they were getting bigger as I went down. That's how I knew I made a mistake. All right, let's go plug in 2. So 2 minus 2 is going to be 0. So this is going to be 0. Well, 3 to the 0 is 1. And negative 2 times 1 is negative 2. And negative 2 plus 4 is 2. See how I said they're getting bigger? I know I'm doing it right if that's what's happening to this one. All right, I'm going to plug in a negative 1. Negative 1 and negative 2 make negative 3. So negative 2 times 3 to the negative 3 plus 4. Remember, you're going to have to move that down to the denominator. So that's going to be 3 to the 3. We're going to erase this one up top. So that is negative 2 over 3 times 3 times 3 is 27 plus 4. All right, the easiest way to do a negative 27 plus 4 is to take your 4 off to the side. All right, so I'm going to take my 4 off to the side. I had to erase to get some room. Negative 27 plus. I want 4 to equal something over 27. So I have to put the 4 over 1. So 1 times 27 will give me 27. So 4 times 27. So 27 times 4, 28, carry the 2, it's 108. So that is 108 over 27. So 108 minus 2 is going to be 106 over 27. And that's fun to work with, right? I don't know why I jumped down there and did the negative 1. I did. Doesn't matter. As long as you do all of them, it doesn't really matter the order you do them in. All right, let's jump back and do that 1. 1 minus 2. So negative 2 times 3 to the 1 minus 2 is negative 1 plus 4. So you're going to have to bring the 3 to the negative 1 down and make it 3 to the 1. So now you have negative 2/3 plus 4. I'm going to take the 4 over here to the side and put it over 1 again. I want my denominator to be 3. So 1 times 3 is 3 and 4 times 3 is 12. So I'm going to change my 4 to 12 over 3. So now they have a common denominator. You can add them. So 12 minus 2 is 10. So that's 10/3. All right, last one we're going to do, drum roll, right? This was a long lesson. Sorry, you guys. I bet you're glad that we're almost done with this lesson, right? All right, so we're going to put a 0 up here. That's 0 minus 2 is negative 2. So you have negative 2 times 3 to the negative 2. Put it over 3 to the 2. Erase the 3 to the negative 2. That's going to be negative 2 over 9 plus the 4. All right, take the 4, put it over 1, set it equal to something over 9. 1 times 9 is 9, and 4 times 9 is 36. So I'm going to take the 4, I'm going to change it to 36 over 9. 36 minus 2 is 34/9. Okay, I'm going to erase this so it doesn't look so busy. Go ahead and plot those points. All right, so I can't do 5, negative 50, and I can't do 4, negative 14, but I can do 3, negative 2. 3, negative 2. I can do 2, 2. I can do 1, and 10 over 3 is about 3.5. So 1, about 3.5. I can do 0, and that's going to be 3 and something. And then negative 1 and 3 and something. Make that one a little bit bigger. All right, do you see how it doesn't touch the line? It just goes gradually. And look, we did the right line. We said that if k was 4, then y was 4. So we did the right one. So y is what relation to 4? So look at all these. And what relation are those to 4? All right, if you said they were less than, then you were right. And so the domain is all real numbers. All right, so if you need to ever pause the video while I'm doing it, don't feel bad, okay? So I'm going to go to your lesson for these 2 weeks, and I'm going to scroll down and show you what your homework assignment is for this one. All right, you see the 7-2 graphing with transformations. Your homework is textbook page 447 to 449, 1 through 4, 16 and 17, 19, 21, 33, and 38 and 39. And so tomorrow we're going to do the rest of 7-2. It'll be part 2. You'll have a homework assignment from the textbook, and then you'll have your mandatory upload, your 7.2 standardized test prep worksheet. So as of right now, you should have uploaded a 6-6 worksheet, a 6-7 worksheet, a 6-8 worksheet, a 7-1 worksheet. So you should have uploaded 4. And then tomorrow you'll upload the last one. Now, since we have a holiday on Friday, you really can just catch up on your homework assignments and your downloads and just make sure everything on this right here, 6-6 to 7-2 has been caught up with. All right. Thank you guys. I'll see you tomorrow. Adios.